Oh, yeah. I think we're back at it again, Anthony.
Yo, what's happening, Miss Juju? Doing all
Chilling.
right?
I'm doing good. We are here. We're alive. We got 300,000 in the building. We thank each and every last one of you for taking your time out to support our galaxy and beyond with Anthony and Juju. We really appreciate that. Shout out
Most
to
definitely. Most definitely.
I can't give my heart.
Yeah.
Go ahead, Anthony.
Yeah, I just
Don't get
want to
more.
say thank you for showing up, coming to get this interesting conversation about the cosmos. You know what I'm
Yeah.
saying? This is what I love to do. This is my quote unquote lane.
His
Um,
happy place.
yeah, I like to get it in with the cosmos. So, and most
Um,
definitely um, passing on what I know and how I understand it, which is what I think is very important when you can relay what you learn, whatever it may be, to reality,
mhm.
and that's what makes science so great, in my opinion. You know, ain't
Yeah.
nothing wrong with, what you believe or how you believe when it comes to what motivates you. Ain't nothing wrong with it. But when you're talking about answering questions and understanding the natural world, I don't know. I don't see any other way to be able to do that is through science. You know what I'm saying? So
Right?
I love science.
Me too. Technology is so neato.
Most definitely.
Yeah. So where are we? I think we're on season 2. This would be episode 3 on stellar evolution. And so we're going to reiterate just a few things, to catch up some people that may not have been here the last show, but maybe go through
Hmm.
some stellar characteristics, maybe a little bit of stellar anatomy or structure. Yeah, stellar structure. And then we're going to talk about some special type stars. A special type would be any of those stars that wasn't in the first category of letters we gave you last week. I wonder
Hmm.
if anybody remember them. I'll give you a few minutes before I tell you. If you think you remember them, or remember any of the neat ways to try to remember them, like the acronym ways, then let us know. Even if you got a few letters, I just want to gauge the audience.
Oh yeah.
But we're gonna talk about some different types. I think what you got. What's the one star? Is that a type W or
Yeah. It would be. It's a special class.
special?
It's actually it's something that we recently, well, not recently, but it was discovered. These types of stars were discovered well after
Mhm.
that chart was
That
established.
the Hertzsprung
So
Russell chart, right?
yeah, after
Got
the
it.
those after those classifications, those letters, the O, B, A, after those stars, after that star classification chart came out, and this goes back to like the late 1800s, early 1900s.
Mm,
Well, with the new technology, new telescopes like Hubble and Webb, and some others, they
right.
found different types of stars that wouldn't fit in any of these classifications.
Gotcha.
And the most exciting one to me is the Wolf Rayet
You
star.
weren't supposed to give it away yet.
Oh, I'm sorry. But yeah, it's
Oh,
that
that's
that
just
one there. It's We're gonna get into that one there. And
yeah.
there's a few others. You have a C, an S, I think an L.
L. I saw an L. I kept seeing the letters and I'll see this L and I'm like, what is that?
Yeah, but
But now I know.
a lot of those W's were earlier. They were classified as O-type stars.
Mm, Got
And,
it.
and then, like I said, using better technology like Webb and Hubble,
Mm-hmm.
they were able to get better spectra of the stars and came to find out there's something totally different. So
That's pretty dope. So
something outside of the norm.
outside,
What would that be? Oh, a phenomenon.
a phenomena. Say it again. Something like a phenomena. Oh my goodness.
But
Um,
they can explain it. There's an explanation for them. So and that's just different.
do you want to do a little quick shout out before we like get into it?
Oh yeah.
Yeah,
Oh yeah. Who we got in the house? Mac Rob, pseudo killer official. Peace, my brother. Miss Felicia Bennett. Thank you for your service, madam.
fact.
Who else we got in here?
What we
Kick Doe Low in the house.
eight
Appreciate you,
hundred
fam.
thousand in the building.
And Chilimboy, my road dog since day one. Peace to you, my brother. Appreciate
Did you
you.
get Mac Rob?
And I think Ken expressed to me that he'd like to get on the panel sometime. I told him he always welcome.
Then he can come on the panel now. Shoot, come to
Always
this
welcome.
company. Um, we shouted out Mac Rob, right? I know you
Yeah,
did.
yeah, it was the first one.
The shout
That
out
was the
Mac
first
Rob.
one.
Oh, that's why. Well, you get the first and the last.
Yeah.
Okay, so I'm gonna try to be a little bit more serious. I'll be so goofy sometimes, but
Mm-mm.
this
Just
is
be Juju, baby. That's just be Juju.
yeah, this is super fun for me, but it's also very fulfilling, right? Because even with the show, even when we're dealing with astrophysics, there's a lot of other things that I'm actually learning that's
Mm-hmm.
connected to it, but that's not really it, right? But they just goes to show that we actually do have a place, right? Some agency in this thing we call science. That's my favorite part of doing this show because Anthony has all the knowledge about the science, but then I wanted to be able to add something to it, right? Bring different types of resources, maybe
Mm-hmm.
introduce you to some people that are involved but also that look like us, like we're not any type of exclusionary group, right? But we do
Mm-mm.
understand the importance of, especially for our children, of having someone that looks like them that is doing something super awesome and great. Like that's just a manner of giving, more empowerment, right? So that's the best part for me. So with that, I want to say Happy Women's History Month, and I I, I haven't really, you know, um, had to sit down with Anthony and say, "Hey, we're going to do this," but I kind of suggested it. But I think, in I'll give you confirmation next week. That we're going to, for the most part, be featuring our women who are involved in these scientific endeavors and doing some amazing work. Whether it's on the field and astrophysics or someone who's actually running the whole joint. You know what I'm saying? Like they're the managing director or or whatnot. Of some of these projects, and that's just equally important. So yeah, shout out to the women, shout out to African American women, shout out to African women in diaspora, and shout out to our continental African women, on the continent doing great things. And then I also want to shout out to everybody, every human who is included in this endeavor to really learn more about who and what we are and how we got here. I think that's my favorite part. So, with that said, this is our Galaxy and Beyond with Anthony and Juju, season two, I believe, episode 3. Going to get into some characteristic structure and special star types. So, Anthony, I got this thing on the screen. Maybe people are sick of hearing about it, but let's go through it real quick because I guess I want to reiterate that this is an important tool for scientists This is all things that I learned. So this is like always my final exam with Anthony for the session, right? But this is an important tool for scientists. And as we've read, and I provided all the source materials in the description, that this tells us everything we need to know about a star. Just like the periodic table for chemists is pretty much their foundation of everything they need to know to do what they need to do. Well, the Hertzsprung-Russell, this diagram is just that for astrophysics. So and this has all to
Mm-hmm.
do with the star characteristics, and that means luminosity, what is it, magnitude, their size, their color, what's some other characteristics there? What's
The temperature.
temperature,
Um,
metallacity, if I said that word right?
yeah. The and they're basically their structure.
Yeah,
You
their
know what
structure.
it's telling you what they're doing
Hmm.
pretty much. Which is fusing hydrogen, but
Hmm.
you know the more massive the star, the more elements are going to be produced by that star. And as you get to the bottom of that chart, the, and to the right, you
This way,
know, the
fun.
smaller and the cooler the stars are.
Let me
So
move it. Let me move the chart.
and if you look up at the very top, okay, that's where the letter classifications are for each
Oh, at
star.
the very top,
Yeah.
OBAFG.
So everything you need to, everything, all the information we know of or understand about
Absolute
stars
magnitude.
is listed on this one chart.
Yeah,
This
the
one
magnitude
chart tells you everything.
and the magnitude was interesting because you have what they call it apparent magnitude, which I guess is just whatever position
Hmm.
on Earth with the naked eye, and then have absolute magnitude because they found that to be problematic, and that was the old way of measuring the stars a magnitude.
Hmm.
So they do absolute, and how is it? It's 10 parsecs from Earth, which would be 32 light years, because 1 parsec is 3.2 light years. So yeah,
Hmm.
it would be the magnitude if it was 10 parsecs away from Earth.
Yeah.
Um, but 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 that's called absolute because they set those parameters for how you are to come to that magnitude
Hmm.
result. Yeah, I thought that was pretty neat. Luminosity. We talked about that in the classification of stars. You have stellar class, stellar class, stellar type, and then you have the luminosity of that, which
Hmm.
is stellar class or stellar type.
And
And
we don't want to get luminosity confused with brightness
right. It
because,
has to do with the power. Luminosity has to do with the
yeah,
power, right? That
exactly.
the
It's
star,
it's more luminosity is more about the energy output.
the energy output.
Yeah.
Yeah, that's dope, right?
Hmm.
Um, but that's counterintuitive, right? Because
Exactly.
luminosity,
Yep.
light, see, illuminated. Yeah, you know how the pseudos like to do it.
Hmm. That's the light.
Oh God, nah, really,
I
it's the
was I was
energy.
in the dark. Now I'm in the
Nah.
light.
So yeah, but those are the major characteristics of stars. I think one thing that I saw though when we're talking about special types, and they have a different m- metallicity to them. Am I wrong or
Yeah.
right? Right?
Hmm.
Okay.
Yeah.
Yeah, and I think that the metallicity metallicity aspect or characteristic is what make them specials because they stand out as far as
Hmm.
some of the normal metals, and I'm saying normal because that's what we're used to seeing. Whereas every once in a while you have an anomaly, right? Anomaly in nature that happens,
Yeah.
and they're showing different metals or different characteristics within that star. Did I get
Hmm.
that somewhat right, Anthony?
Yes, ma'am. That was excellent.
Yeah. But yeah, so this is just kind of a run through because we went through class and types, and I thought that was really fun, and we have some really pretty pictures for you. But the Hertzsprung sprung Russell, this diagram is
Hmm.
what the periodic table. This diagram is to astrophysics what the periodic table is to chemists, and that's a very important piece or tool. Like that's the
Yeah.
foundation of anything they're doing as far as their work. So very important. I think that's
And
pretty.
this also, you know, it explains the forging of the elements that's listed on the periodic table. So it works,
Right.
they work well together. You know what I'm saying?
Nice, right. That's the best duo to have. It's like, no.
You can't go wrong
Yeah,
when you're dealing with that periodic chart. That
right.
periodic chart go through so many different areas of science,
Hmm.
but it lines up with this one too. You know what I'm saying? So it fits in astronomy, it fits in biology, it fits in chemistry. You know what I'm saying? That periodic chart ain't no joke.
Yeah, it's not. But again, to I think I'm just don't remember my chemistry teacher doing that. But to lead off with the periodic chart and say, these are elements from stars or elements forged from stars, like that's the first thing I will ever say if I was a chemist teacher to any students, especially in high school chemistry class or whatnot, or even introducing a younger child to chemistry. Like that's I believe that's how you should start off. Like, how fascinating is that story alone when it comes to stellar evolution, that
Hmm.
all those elements are like
And
remnants
and
of.
we're gonna. I'm sorry. Go ahead, Miss Juju. I'm
No,
sorry.
just saying all those elements are remnants of stars. I'm still fascinated by that because once I found that out, I was like, wow.
And when we get to the structure on that slide I sent you a little while ago, we'll see how those elements fit onto that um, periodic chart on the core of stars. We'll see it in the structure.
But which one is that? Because I have this one. We can go to it now because that's the characteristics of stars. And if
Yeah.
you want to know more about the stellar class and stellar types and a little more, just watch last week's show because we went in really good. It was really fun. But I was gonna put
And
this one. Are you talking about
they can go back and look at that show I
you
did
and
on.
Bobby too?
Yeah,
Is that
that one.
the
They can
pseudo
look at
killers?
that one too.
Oh man, I,
So
sh- I should have added that. But definitely check that one out. Shout out to Zay. Yeah, I'm definitely gonna add that to the next show because that was a good show. Which diagram were you talking about? The one from the SDDS? I'm saying it wrong.
no, it's just a slide. I just emailed it to you right before the show started.
Okay, okay. Let me check that out real quick because I'll put this one up, but I have this one for now. If you want to get into star structure, or you need the other one real quick, I'll get it real quick. Hold on. Let me
Oh yeah,
see.
I can talk about that one too. See that one, this one,
Oh,
okay, this one, the one I sent you is gonna break down the core. So this one is good for the
okay. Which you want to do the
outside of the
corporate?
core.
Because I like this one. I like
Yeah,
this one you have too.
I can talk about this one while you get
Oh,
the
I'm
other
ready
one.
for either. Where you want to start?
We can start with this one. We'll work our way
Okay.
in.
All right, all right. That's what's up. All
Okay,
right.
so when you're talking about the structure of a star, as you can see in this diagram, okay, there at the very center you have the core,
Right.
and around the core you have what's called the radiative zone.
Mm-hmm.
And there's a lot of fusion going on in that area as well. You know what I'm saying? Because of the heat and different elements are moving. But in that core, with that fusion, when you get that photon, when the two elements, when the two atoms fuse, they release a photon, and it's working its way up to the surface through the radiative zone. And it takes a long time for that photon to actually get to the surface and come out as light. From the time that it leaves the core to reach the surface, they say it could take about anywhere from 100,000 to 1,000,000 years. And that's because that photon, when it leaves the core, it's at gamma ray strength, but it's bouncing around off of other atoms and molecules in the radiative zone. And it's going to be doing that for thousands and thousands and hundreds of thousands of years. So then the next zone you have is
the convective zone.
The convective zone.
Mm-hmm.
And that's like where, you know, what convection is, where, you know, heat rises and the cooler things sink.
You're right.
So the warmer parts, which are coming off the radiative zone, is moving
rising
up
to the top, right, to the surface.
Yep, it's moving up, and then the cooler parts are coming down.
Towards the core, yeah.
Because, you know what I'm saying?
So one thing I did learn, and so I heard that it's actually they can't really figure it out, but how the outermost part of the star is hotter than what's in the innermost part. But you kind of explain it, but there's like another dilemma to that or something.
Yeah, like, the corona. Mm-hmm. The corona is basically the outer atmosphere of the sun.
Correct. You can see it.
You'll really be able to see it during the eclipse.
Eclipse, right? You can see
what I'm saying?
Really good.
Because the sun is so bright to where it just blocks it. You can't look at the sun with the naked eye. Never, ever do that.
Never do that. Don't listen to them pill twins. Don't listen to nobody.
So if you don't look at it with your naked eye, do not ever use an aid either.
And he said he would not recommend that if you
never, ever.
If you don't want to go
no circumstances. But yeah, but the corona is pretty much like the outer atmosphere of the sun, and yes, it's been said that it's hotter, you know, or just as hot as the center of the sun. So I'm not for sure about that phenomenon.
Okay.
I'm not 100% sure about that, but that's something we can look into. But
did you answer Zane's question already?
No, it's nuclear fusion. What happens in stars is when they're fusing atoms together. Fission is when you split an atom, and that leaves all kinds of nuclear waste. That's like an atomic bomb, a fission bomb. They split the atom where the stars fuse them together.
Do you want to answer this question, or you want me to?
You guys cover what's going on today, like Haiti.
Do you want to answer? Or do you?
I'm sorry, Jambazi, but this is not that type of show. We cover the cosmos on this show, so. Right. No, we don't deal with world affairs and politics. No, not over here. Over here, we're dealing with the cosmos and the universe and what's going on out there. So I apologize, but no, that's just not what we do here.
But I like to think that what we do here is definitely reinforce scientific literacy, which I feel would be helpful in any situation, regardless of the political outcome. Yeah.
Most definitely.
They can start doing things for themselves. We don't have to rely on the government, you know. Like, it's even with us, a lot of times I tell people, like, make sure you know how to filter water or make a water filter, you know, even if it's like I think they use charcoal or special rocks, so you have those things. Because in Florida, when it comes to a hurricane and you don't have access to like the water system, you know what I'm saying, and things like that, which happen for like 2 weeks of time, like you won't be so stressed if you know how to do like simple things, you know.
Yeah. Really.
So I'm
real talk.
So scientific literacy, and then understanding things that are scientifically literate but applicable to real everyday life, especially in emergency situations, is definitely something that we do, even if we're not trying. So that is our part with that. And I just wanted to add that on, but I don't know if it's a troll or not, but you know, we could talk about it. You feel me? And shout out to regular Joe. Mucket.
Mhm.
What up, fam? Thank you for joining us. So yeah, you talked about the radiative zone, the
Yeah.
convection zone. You talked about the core. You
Hmm.
talked a bit about the corona. So my question is like, so anything that has to do with astrophysics, I know that usually we're either going to look at the star as the sun as our like kind of source material or comparison, or the Earth, or whatever is happening in our solar system. We're probably going to use that as like a guide, right? Um,
Hmm.
that's the template. So the sun is this would be the template or to most stars, or like this whole the structure.
Yeah. For yeah, the structure is pretty much the same. It's just the material or the elements within the sun and the star, which is mostly hydrogen. But
Right.
when you get down to like the red dwarfs and stuff,
Mhm.
they're formed out of some hydrogen, a lot of lithium, and then I think the brown dwarfs they're mostly fusing deuterium. You know
Mhm.
what I'm saying? But for the most part, they're all made of hydrogen. They all have a core. They all have a radiative zone. They all have a convection zone.
Okay, got it. Just,
It's just the mass of them is different, which
right,
affects the temperature. You know what I'm saying?
right. So
And
go ahead. I'll let you finish with that, but something I wanted to get into. Go ahead.
but did you get that one of the core?
I did. So I want to show you, I'll show you that one, but I also wanted to show this one too, because I
Okay.
wanted to know if you could explain this part real quick, since we're talking about the core.
Hmm. Yeah. Okay. So this one. I've never seen this before. This pretty cool here.
Do you know what
But
I'm talking about though? Like how they say that, like the bigger mass stars, it'll do convection more to the core, the
yeah,
radiation on the side and on outside, and then like our star, it does more of radiation towards the
yeah.
core and then convection on the outside. So I don't
Hmm.
know if you want to explain that a little bit.
Okay.
And big radiation for smaller stars or something.
What's happening here is okay. If you see down here at the bottom right, the little symbols, you have a convection zone
Mm-hmm.
and the radiative zone. So in the core of a more massive star, you have convection going on. That's pretty interesting now.
Mm-hmm.
And in the core of a star, average star like the size of our Earth, our sun, you have the convection zone outside of the core, but that's the radiative zone. And then in the smaller red stars, it's all convection.
Mm-hmm.
So that's pretty interesting. I've never seen that before. That's pretty dope there, Ms. Juju.
But
But
you know what it is though.
yeah, the
Yeah,
convection, you know what I'm saying, is like we were saying where the hot stuff rises and the cooler
right.
stuff. And the radiative zone is where that light is escaping.
Mm-hmm.
So it's kind of opposite. The more massive stars is it's opposite from the smaller mass star.
Correct. I thought that was a great illustration, and it was easy to understand how and why and what characteristic of a star does what, right? Um,
Yeah.
so yeah, I thought that one. But Zane has a question, and shout out to Ronald Perkins. Thank you for taking the time out to support us. And we have 120,000 in the building at the moment. We appreciate you all who stopped through to get a little bit of our galaxy and beyond. And we're still on stellar evolution, dealing with characteristics, star structure, and then we're going to talk about some special types of stars. Yeah. But Zane's question is, what's the difference between a flare and a prominence?
Okay. Well, the a flare is basically okay. Let me start with the prominence. The prominence is like a loop on the sun. It's kind of connected to the sun like an arch. You know what I'm saying? And those are caused by, just magnetic forces and all that kind of stuff on the sun. But it looks like a big arch. So that would be the prominence. It's still connected to the sun. And I believe, if I'm not mistaken, when it breaks and it shoots out, it becomes a flare. So I'm thinking that the flare starts from the prominence. And I'm going to have to look into that to be 100% sure on that, is that Zane? But I do believe that, I know the prominence looks like an arch and it's still connected to the sun itself. And then once it kind of like breaks off and it flares out. So that's what they call the solar flare.
I was trying to find a picture real quick, but I don't think that does any justice.
Yeah, look it up. Shit, I want to know for sure.
What about the prominence?
But I believe that's what, if I'm not mistaken, that's what it is. Once that prominence, or if it breaks and separates from the sun, then it becomes a flare. And that's what, we don't want to hit Earth at a very, very high strength. Because that'll knock out all our electrical systems.
Okay. Let's look at it real quick. Thanks for the question, Zane. Can you see?
Oh, yeah, most definitely. Yeah, see how it's connected? I think that would be a prominence.
So
that would be called a prominence.
It says solar eruptive prominence as seen in extreme UV light on Earth. Also known as a filament. So this is also a filament. Remember when we talked about that?
Okay.
Don't get it confused with the pseudo stuff. When viewed against the solar disk, is large, bright feature extending outward from the sun's surface. Prominence are anchored to the sun's surface in the photosphere. So that was right, what you said. And it extends outward in the sun's hotter outer atmosphere called the corona. Yeah. Do you want me to read more, or does that answer the limit? You want to go to
Does it get into the flare on there?
It don't say, no, because it was separate, but I could let's just do it right here. Let's do solar flare.
Hey, you see how they got the approximate size of the Earth compared to that prominence? So the Earth can go through that thing. Like, you see what I'm saying?
Right.
See how small the Earth can be?
So which one do you? It says, what is a solar flare? Let's see. So it says solar flares are giant explosions on the sun that send energy, light, and high-speed particles into space. These flares are often associated with solar magnet. And therefore, I'm trying to see if it tells the difference between the two. But moving towards another solar, that means that more flares will be coming. It's telling about the biggest flares.
Oh, okay. So it don't really.
No, this was in 2003. But you know who I will ask in a minute? I think
ChatGPT.
You already know it.
And then we'll get into that core. This thing got interesting to me now.
It's okay.
Yeah.
And of course, whatever we get the ChatGPT, like we could source it up. It can be sourced. So let's just ask.
No, Zane. I think the prominence is. I don't think it's like the sun's atmosphere. I think it's actually material from the surface of the sun.
But
I think that's what it said.
So hold on, let me ask him real quick. What is the difference between solar prominence and solar flare? Let's see what it says. It says solar prominence and solar flares are both phenomena that occur on the sun, but they have distinct characteristics. Solar prominence is a large, bright feature extending outward from the sun's surface. composed relatively of cool, dense plasma held above the sun's surface by magnetic forces. Can last for days or even weeks, appearing as arches over loops, are often seen along the edge of the sun during solar eclipse, appearing as a red glowing loop. A flare is a sudden intense burst of electromagnetic radiation and energetic particles from the sun's surface. They're caused by the release of magnetic energy stored in the sun's atmosphere. They, they can occur in active regions of the sun where magnetic fields are strong, often associated with sunspots.
With sunspots, yeah. Okay.
Can release vast amounts of energy in a short period, causing a sudden increase in brightness across various wavelengths of light, including X-ray and ultraviolet. So prominences
So
are very stable.
I was right about the prominence, and I was off about the flare.
And flares are sudden, intense, with energy and particles.
And they're associated with the sunspots, right?
The flares are associated with the sunspots.
Okay, so there we go.
Yeah, I think that's a pretty awesome picture of of this solar flare right here. That happened in 2003, I believe. Right, 2003. So yeah, did I miss?
So that's why when you get to hearing about the sunspots, the bigger they are, the more deadly they can be or damaging they can be because of the intensity of the flare that they will release. You know what I'm saying? So, and right now the sun is moving into what they call solar maximum.
Yeah.
So I know, if anybody's heard anything about that, they're moving into solar maximum. The sun is moving into solar maximum, so there'll be a lot of activity going on the surface of the sun with sunspots and solar flares and that kind of stuff. So yeah, it's pretty deep.
It's pretty
deep. Appreciate that, Zane. Appreciate that.
Okay, so now let's get to this part. We didn't skip anything, did we?
No, that was good. We still on track. Yeah. Okay. Now we talked about the what was going on as far as outside of the core of the star. So now we get into the core of the star, the structure of the core. So the top layer, which is yellow, that would be helium. So everything outside of that top layer on most stars would be hydrogen.
Shout out to Aoife. Thank you for coming. Go ahead. This is the one that I was trying to remember. I was so proud I remembered this.
Yeah.
Different fusion levels or classifications,
Oh, yeah. So these are the elements that are on that periodic chart. This is how they're forged.
Right.
And when the star, when a star stops fusing, when it runs out of hydrogen to fuse,
it'll fuse helium.
It builds a shell around the core. And now you're fusing helium.
Iron zinc.
When it runs out of helium, it's gonna
carbon
produce a layer of helium, and the core for each element the core shrinks. It gets smaller and smaller. And as you can see, you got helium on the outside, then you have carbon, you have oxygen, you have neon, you have silicon, and then iron in the middle. Once it fuses all of its hydrogen, it's going to start to fuse helium. So helium would be its fuel. So like I said, it's going to build a shell. And that shell, the core of a star basically is like an onion. It has layers on it. And those layers are the different elements. And along those boundaries, like where the hydrogen would be touching the carbon and the carbon would be touching the oxygen, you have fusion going on in those little boundaries as well. And that's how you get in a lot of your isotopes and things like that.
Right.
Our star, once it runs out of hydrogen, whatever helium and carbon and oxygen it has produced in that process is going to be locked in. And all the outer gases are going to float away. And that's going to be your white dwarf. And you get white dwarfs. The reason why it stops there is not massive enough to have that gravity to overcome what they call electron degeneracy. And what that means is electrons do not want to come together. You know what I'm saying? They don't want to do it. So a less massive star is not massive enough to force those electrons to come together. So the electrons themselves are holding the star back from exploding or collapsing in on itself. And that's a white dwarf. So that's why they're mostly carbon, some oxygen, maybe some helium. You know what I'm saying? That's why they stop there. But a more massive star will be able to take that oxygen and start fusing neon. So when that happens, core gets smaller. And each time the star begins to fuse a different element, it puffs up. If it's massive enough, it'll come back down, but it's gonna get hotter and hotter. And then when it does it again, it'll puff up. So that's what we call the asymptotic branch. Once it finishes hydrogen, it blows up, starts to fuse helium, then it comes back down. And then once it finishes helium, then it could go anywhere. You know what I'm saying? Anything could happen then. But once you get past in each phase of it, it happens quicker. So take, for instance, the sun, it takes 10 billion years to burn through the hydrogen. Well, when it gets to helium, then it's going to take 5 billion. And once it gets to oxygen, then it's going to take, 2 billion or whatever. The numbers get cut in half till it gets all the way down to silicon. And silicon takes 1 day. It'll burn through all the silicon in 1 day.
Yeah, I read
what I'm
that.
saying?
I was like, what?
Yeah, that's wild, ain't it?
It's done. And got 24 hours.
Yeah.
Boy. From 1 billion years to 24 hours.
That's crazy, ain't it?
Fascinating, bro. All I want to say is you better preach, Anthony. You better preach this astrophysics. Boy,
hey, that's
about to throw the handkerchief at you.
Now, when it gets down to iron, now that's where the mass of the initial mass of the star really comes into play. You know what I'm saying? Once it reaches iron, now its gravity is going to take over because it takes more energy to fuse iron than it releases. And remember, it's the releasing of the energy that gives you that equilibrium between gravity collapsing itself and the sun and the star blowing itself apart.
Mm-hmm.
So now you take away the releasing of the energy. So depending on the mass, you're going to get a neutron star or a black hole. But there's also the fact that if you can, I forgot what it's, it's on the tip of my tongue. I was just reading about it too. But anyway, the star is going to obliterate itself. You know what I'm saying? It's not going to turn into a black hole. It won't leave it's just going to annihilate itself. And what happens is all that mass of that star bounces down onto that iron core. And you have all these elements here. Don't forget, you still have all that shell of elements. All that mass bounces, it hits that core and it bounces off, and they call it it's on the tip of my tongue.
Because I can't help you.
But anyway, and it just obliterates itself and it blows itself to pieces. And that's how those elements get dispersed throughout the universe through the supernova. You know what I'm saying? So that's pretty much how we get those elements on that chart.
You ain't talking
And
about
this is the way we classify those elements. Hydrogen would be the most abundant, which was created in the Big Bang, and a little bit of helium, and an even smaller amount of lithium that came from the Big Bang. So everything else that we know of is created through that process.
Are you talking about when the core collapses?
Yeah, the core collapse. That's what it is. Core
Supernova,
collapse.
ain't it?
Yeah.
Supernova.
Yep. A type 2 supernova.
Mm-hmm.
You know, the type 1A is when the white dwarf is basically stealing material from its counterpart. That's the type 1A supernova. And when it reaches that Chandrasekhar limit, then it blows up.
So,
But the type 2 supernova happens from core collapse.
got it. Type 2 supernova. But so can you just answer this directly? I know you did, but
Well, no, a white dwarf, it won't reach iron. It stops at helium. When the star only the most massive stars reach iron, get down to iron. So
good question.
you don't find much iron, if any at all, in a white dwarf. It's mostly carbon, some oxygen, some helium, but they're mostly carbon. The white dwarfs are. And like I said, that only the most massive stars reach iron as
Is there a stage for every elemental release?
and well, yeah, it's a certain temperature and a certain amount of pressure that has to be applied within the core. And when you get down to a neutron star, that means that the mass of the star, if the star was massive enough to overcome the electron degeneracy, and now what it has done to reach a neutron star, you've got the electrons pushed into the proton, which makes them neutrons.
Right.
You know what I'm saying? So that those stars are composed of all neutrons, and that's why they're referred to as neutron stars.
That is fascinating.
And then with the black hole, you got even an even more massive star that has forced all the neutrons together. You know what I'm saying? So that's where we're stuck at when it comes down to the composition of a black hole, because we don't know exactly what it is because it doesn't emit any kind of light.
Right.
So we don't know what happened when you fuse neutrons together. We hadn't gotten that far.
I don't know if I want to find out. That might be a little.
Yeah, that sounds like it might be something deadly.
Yeah, I mean, it might be that Thanos snap.
Yeah. So remember, when you get a white dwarf, it's from a less massive star, and it doesn't the electron what they call electron degeneracy keeps it from collapsing any further. So the fact that the electrons do not want to come together, that's what's holding it up. And with a neutron star, those electrons have been forced due to the mass of the initial mass of the star, have been forced into the proton, which gives you a neutron star.
Joe funny talking about them self-hating electrons hate coming together.
Yeah, they do. They can't stand each other.
That's crazy.
It takes somebody with a mean to get them together.
Yeah, y'all need to stop, because that sounds like some people, but we ain't gonna talk about that. So he's talking about solar maximum. We did do this on a show. I think we did this on a show when we addressed one of the Pill brothers when they was talking about some things, but
yeah.
Go ahead. Yeah, it is a cycle. But I'll let Anthony go ahead and give it to you easy, because I'll be like a toddler trying to explain it to you. But I still
Well, sometimes that's what we need, though, Miss Juju. You
right,
know
right.
what I'm saying?
Yeah,
Sometimes, like they say, you got to crawl before you walk.
yeah. But
You know what I'm
but I'll say this to him then. It is a cycle, right?
saying?
Going into maximum. I think they happen every 11 years. Is
Yep.
that it's something like that? Yeah. We did discuss this in that show. If you want to go back and watch it, it was pretty cool. We addressed some things that one of the Pill brothers were saying about the sun, making like that corona hole was some magical, fascinating
Hmm.
thing,
From the Lord of the Rings or
yeah, that
something.
never happened before, which it happens all the
The
time.
Eye of Zion or some
Yeah,
shit.
that is. So we addressed that and we went over
Mhm.
the sun cycle. But that's my part, and I'll let Anthony maybe expound on it a little more for you.
Well, I mean, that's pretty much it. I mean, it's an 11-year cycle where the intensity of what's happening on the surface of the sun, it intensifies. You know what I'm saying? So, I mean, that's basically it. It's an 11-year cycle, and what you have to do is just, pay attention to the sunspots. The more sunspots, the closer, we are to maximum, which is what's happening now. You know what
Right.
I'm saying? And it's those solar flares will get more intense, you know.
So
So
then I'll go back to, so why didn't Dogon ever talk about any of this stuff? Because you can like
mm-mm.
see some of that stuff with your naked eye.
Hey,
Like, why didn't he talk about none of that? I mean, I'm still gonna stay on that because yeah,
you have to.
we gonna make sense of it, right? We gonna
Oh
let
yeah,
you know why it ain't possible. I
you,
mean,
you you have to. But
come on,
back
not
to
the
the
return of wait, me say not the return of what is it, Sogan?
yeah, that's what it was. The return. That's what it was. The Eye of
Ah,
Sargon.
that's funny. Yo, shout out to From Then Till Now. Thank you, fam. I know you like recently subscribed or whatever, but yeah, we're back at it again.
Oh
Where did
yeah.
you want me to go back to?
We're gonna talk the Wolf Rayet star.
Oh, you ready for that, y'all? So wait a minute. Let me preface by saying now we are getting into special class types, because I think
Mhm.
the last show we talked about spectral classes and spectral types, where this is a special class of spectral classes. That was
Yeah, they don't fit into that OBG,
yeah.
OBAFG
No,
M.
go ahead. So
Yeah,
I do it MKG FAB. Oh,
there you go.
M is coldest, O is hottest. But I do it
Hmm.
backwards. It matches the dyslexia. Um, yo, okay, let me get to it. All right, y'all give me a minute though. Go ahead and sing for him while I get this together. Let me stop. There it is.
Yeah.
Ooh,
Oh,
baby. Oh my God. She
them
beautiful.
bad boys, they're deep.
She's a W type.
The W.
Still doing my homework on this, so I'm just listening. I'm in class too.
Now,
All star, baby. She
this
beautiful.
is a special class of star, and the reason why is because the classification, the letter classification that we've been giving you, it's been around for a while, and
Right.
science updates itself, self-corrects itself. It's self-correcting. you know,
Yeah.
so when the technology gets better, we have to do better.
Right.
So what was classified as an O-type star is now classified as what we would call a W type, which is a Wolf Rayet star. And what makes these stars special is they're the most massive, they are the hottest, and there's no hydrogen present in their spectrum, mostly helium and other elements. But There's no hydrogen. So that's kind of odd to find a star that doesn't contain much, if any, hydrogen. They're very, very massive. And they were at one time classified as O-type. But like I say, when the technology got better and we were able to, get a better spectra, then they understood that this is something different. Now there's other special types, but they're not as exciting as this, the wolf red stars. And this, what you see, the illustration here is what most of them do. They they acting what we would call acting bad. They just blowing stuff everywhere and just
acting bad.
They acting
Pretty
bad.
ass star, bro.
And some say that they could be in a phase, you know what I'm saying, getting ready to go from blue supergiant to red supergiant. But then, like I said, it's classified different. And there's different classifications within the W. Like we have the sun is a G2, what was it? G2V, I think.
Oh, G2V, yeah, the sun. Sorry.
Yeah.
I'm over here trying to look
it's
more special class type stars at the where am I? The European Space Agency Hubble organization. I mean to cut your bill, but yeah, I left this link so you can do this at home, and it is pretty spectacular. Let me just go ahead and share my screen while you're talking. Go ahead with the wolf star though.
But there's different types, and those different types of W stars are measured or classified by their nitrogen content. So you have W star, then you have WN3, then you have WN4 and WN5.
This was a WN6 right here.
Now this is the what they call the Crescent Nebula. I took some pictures of that. Nice. And it's hard to get that red to come up. Man, that's tough. For me anyway.
Right.
Yeah, that's the Crescent Nebula. That's a pretty one there.
That's beautiful.
But yeah, those wolf red stars, like I say, they are just blowing material everywhere. They're acting up, they're spitting stuff everywhere, and they don't find any hydrogen in the spectra. So that's what kind of makes them exciting. Is it something different? Is it a phase that stars go through? It's just, those are questions that still need to be answered. You know what I'm saying? So for me, that's the exciting part about all this, because there's a lot of questions that need to be answered, that we need answers for, and it could be our children answering those questions.
Yeah, I'm looking at pictures. Please don't mind me.
Hey, knock yourself out. They're beautiful. I'm telling you.
Yeah, this is AB7 Magellanic clouds. So
it's a lot going on in that Magellanic cloud too.
I see. But I do want to, before we do our tribute and wind down the show, I know it's getting hot, but we don't want to have every show be like 3 hours, Yeah. I want people to come in, get a little food to eat, and then, be on their way if they have to be. But so believe it or not, I don't know why people be hating on Wiki, because if y'all ain't know, a lot of the visuals and information, of course, coupled with other source materials, come from Wiki. I'm definitely going to use Wiki. Are you kidding me? These are Wiki pictures. But if you always want to really impress somebody and go a little further, then okay, I got you. Hold on. I did introduce y'all to this last week, but let's go ahead and introduce you one more time. And I actually have a bonus. I think I have a bonus gift. It's going It's gonna be going with my a Women's History Month Woman of Science tribute later. But yeah, check this. Which one is this? Like, so this is crazy, right? This is a star, y'all. This is some type of star exploding, releasing gases or something. I showed it last week, but where I'm at is this is the European Space Agency, and this is like the Hubble organization. So all these are separate stars, and you can click on them, make them bigger, star clusters. And yeah, it's a nice site. I think there's some interactive materials. I usually forget because I be playing on these sites. There's so many of them, but this is one, and these are some amazing pictures. Like, look at this. Like, what I say? This is Milky Way. Oh, this is the Wolf Rayet, y'all, too. Oh my God. Look at that. I knew I saw it. That's why I told you I've seen that star. I seen it, but this was here. And then if you want to get even more poppin', then you can did I lose it? I may have lose it. I think I lost it. Oh, you could take yourself over here. We discussed this last week and go to SkyMap from NASA.
Hey, that's a fact, Kent. That's a fact. We are stardust. Like you say, we are the universe observing itself.
So let's have a little fun. This is full screen. Can y'all see my screen? I'm screen sharing, right?
Yeah, that's dope though.
Yeah. This is full screen. Let me do it like that. So this is the interactive app you can do on your computer. So down here, here's your key, right? So all the blue dots are stars. The orange ones are galaxies. The pink ones are nebulas. And what they mean by exotic? But it says exotic. That's not a dancer, okay? And then your light green ones are exoplanets. So if I push this, it's gonna do that, and then bam, okay. And I think for the most part, a lot of the exoplanets are actually gonna be artist depictions for obvious reasons, people. We could do an artist rendition based on the characteristics from the data that they've gotten. Um, let's go to the blue one. Let me see if I can get a. That's a cluster. I don't want to get a cluster, but they're gonna have a lot of clusters, which I think is pretty awesome. Still,
Yeah. Clusters is where they get a lot of information from. Those are study grounds for stars.
yeah, that's a pretty dope. So this comes from NASA. This is NASA.gov sky map. Okay.
Mm-hmm.
And you could just sit here and just be pushing dots and stuff for the next hour. It ain't even a joke. The Ghost Nebula. That's gorgeous. Okay. So yeah, that's just we have the European Space Agency, Hubble organization, which is basically a gallery of all the pictures that they took, and then you have SkyMap from NASA, which I think are pretty awesome. So I'll remind you of those again. I put the link if anybody have any additional questions or want to add anything to this particular segment of our galaxy and beyond from your expertise. I mean, please do. Sosa or Kent or even Zane, if you want to come up and add your 2 cents, give us some constructive criticism. But yeah, I think it's pretty awesome. And the reason why I always show those, because you already know my advocacy is really for young adults, teenagers, and children. And all these things I show you that are interactive, I mean, that's great for your children, right? To get them actively engaged and involved in this. Yeah. So okay. You have anything else you want to say? Ooh, did I just anything else you want to say real quick?
Yeah, before we go too far, I mean,
Yeah,
get
yeah.
ahead.
Go ahead. Go ahead.
It's
Okay.
this is, I mean, the information we're giving can lead to careers for young people. You know
Correct.
what I'm saying? That's really all I want to elaborate on. I mean, this is information you can take and do something with. We can give you a foundation, to get started, to understanding and relating a lot of this information to reality. So like I was saying earlier, this is something you can build a career on. It took over 20 years from conception to being in orbit for James Webb to come to fruition. 20 years. That's a career. You know what I'm saying?
Right.
That's a career. So this is what we're doing over here. We're trying to enlighten or turn our children on to something that matters. Something they can we're trying to give you guys something that can be used in everyday life as
Right.
far as understanding the processes. No, you might not be talking about stars, but when somebody come to you and ask you where you can't, how were you, what are you made of, and things like that, well, you know the process. What are elements? How are elements forged? How do those elements get to a place where they become a sun and an earth and people and things like that? That's where we're at with it. So
Right.
appreciate everybody for tuning in.
Definitely. So,
Most definitely, Zane. Yes, because there's a lot of them. Even the the,
there
the
are a lot of
support
them.
staffs, you know.
Right.
So and
Yeah.
a lot of excuse me, Miss Juju, but real quick,
Go ahead. Take your time.
a lot of these space programs are, a lot of the work is contracted out to small businesses as well. You know what I'm
Right.
saying?
Right.
So anything dealing with space or the supporting of the space endeavors is a good career. It's a good career. So
That's pretty dope. And I think that's part of we're going to be talking about a couple things, but do we have anything else to say about a special spectral classes or types or characteristics before we give
now,
a tribute?
well, real quick, just to reiterate, those special types, those are stars that were further researched or either discovered once the technology got better than what it was in the early 1900s. You know
Mhm.
what I'm saying? So probably going to be adding things to that. You
Right.
know what I'm saying?
And
So
that's
that's
okay.
basically all it is. And the Wolf Rayet star, for me personally, that's the most exciting of all the stars because it's doing something. It's doing its own thing and it's acting bad. You know what I'm saying? So that's it for me on that part. So yeah, we can get into the tributes.
Okay, I'm making you go first.
All right.
Yeah, I'm petty,
One
right?
more. I
I
need
got
Omar Reed in here. Where Omar Reed at? It's for you, Omar.
I know this one's for you, Omar. He ain't even here. Oh,
Let me pull up.
this one's for you and you and you. Let me stop trying to do my usher.
Yeah. Okay.
Take your time.
This, ladies and gentlemen, this beautiful African American sister of mine, her name is Mugega Cooper.
Yeah.
And I was introduced to her through the series that I always speak about how the
Correct.
universe works. You
She's on
know,
like quite a few
yeah,
episodes.
yeah. That's how I came to know her, and she deals with a lot of planetary science, and you know, she's an astro. Well, I'm just gonna let y'all hear about her.
She Oh, okay. Because I was gonna jump in.
Mugega Cooper is an American astronomer and the lead of planetary protection for the Mars 2020 mission, and is involved with the InSight missions. So y'all can look into those to get a little bit more understanding. But Dr. Cooper, and I'm reading from her wiki page. Dr. Cooper also takes part in programs and speaking engagements to encourage young women or others from underrepresented communities to pursue careers in science and technology. And just a little rundown on her. HBCU graduate, Hampton
Yeah,
University. Woohoo!
again. The
She
other day
also,
was Howard.
yep, she got her bachelor's at Hampton. She got a master's from Drexel University College of Engineering. Um, like I mentioned, she's known for being the lead of planetary protection for Mars 2020 mission, which you know they sent those probes to Mars a few years ago. Um, she earned a NASA Early Career Public Achievement Medal, and her fields is astronomy and mechanical engineering. Um, Her thesis was on the elucidation of levels of bacterial viability post non-equilibrium dielectric barrier discharge plasma treatment. Y'all look that up. And she got I like to go down to, you know, her inspiration. And what inspires her, from my understanding, was her childhood inspiration was Carl Sagan, which, you
Right.
know,
The Cosmos.
yeah,
Yeah,
that series, The Cosmos, that
that's
inspired a
serious.
lot of people, you
Right.
know. And Neil deGrasse Tyson has taken that to the next level. You know what I'm
Correct.
saying? Which he also was inspired by Carl Sagan, and I think he worked with Carl, or either I can't
Under
remember
his
if it was
tutelage.
Carl or
He worked
but
under
but
his tutelage for some.
yeah. And she is a strong advocate for increasing the representation of women and minority communities in STEM fields.
Yes, sir.
So, and she has publicly stated her love for working with children through various K through 12 student initiatives. So, this is someone that, you know, you guys can look into her to get, you know, a little bit deeper, but this is someone that's actually geared her life towards helping young people get involved into STEM and, you know, science related fields. So she's someone you guys can, you know, amongst the others we've given you, because we've given you a lot of good ones all through Black History Month. Just add her to the list, you know. So we are, as a people, making strides, but we still got a long way to go, folks. We still got a long way to go. And the best way that I know of to keep that going is to instill it in our young people,
Hmm.
you know, give them the opportunity to make a choice on, you know, what they want to understand and how they want to understand it. But
Correct.
this, the STEM mindset is powerful. You know, I think I was telling Kent the other day, the superpower is reading, comprehending, and understanding, and being able to apply what you read somewhere. That's the superpower. You know what I'm talking about? So let's keep pushing the STEM, and let's keep promoting those that are pushing the STEM. So for me,
Right.
that's Mugega Cooper. Like
Can
I
I
say,
add
y'all check her out.
can I add something really quick? I think
Oh, yes, ma'am.
the things that I loved about her work. So to break it down for people, like you can read about her, please read about her. We left all the links, you already know.
Mhm.
Obsessed with that description box, literally. Um, she is somewhat like an environmentalist. So when
Mhm.
it comes to like any type of space endeavor, she makes sure that the project isn't like harmful to Earth or humans, and just kind of like regulating stuff, making sure we're not leaving a lot of space trash out there and different things like that. Just trying to ease that. So she's like a space environmentalist in some capacities of her work. And I think that's pretty awesome because, in that way, she's working to eliminate any type of a disadvantageous impact that space exploration can have on either the planet or the occupants and also space itself. So yeah, I thought that was pretty cool. But shout out. And this is our tribute, especially for Women's History Month. And like I said, I wanted to showcase women, especially women who look like us, to so our children know that we do have a seat at the table, right? We are involved. We are actively engaged as we speak, and that there's no such thing as white man science. Not when you have all these beautiful um, faces behind science. So yeah, that's Mugega Cooper. Shout out to you, Omar, because boy, he be in love with some Mugega. I tell you, um, definitely. So I think I'm next, and before I actually go, I want to show you a few things. And I'm not going to read much, but I just want to show you this article. I think everybody will be able to have access to it. It is from the Nature of the Journal of Nature. As you can see, it speaks on female scientists in Africa who are changing the face of the continent. Right. This article was absolutely fascinating. And I already told Bobby Banger I was going to read this part of it because, oh, and I love how we have Kent in the audience. So this is for Kent and Bobby Banger. Um, so basically, this article talk about women in Africa experiencing greater barriers to develop careers in science, technology, and engineering and mathematics than women of other high-income countries. So it talks about those dynamics, but there is one sentence in here, and maybe we get into it that I thought was pretty shocking. Watch, I can't find it now, but it had to do with their endeavors. I'm going to find it. Look, the devil don't want me to be great. um, wow. So my scientist that I was going to speak on, her name is Apanshu Maraping. She is part of this article. Um, and the reason why I wanted to highlight her is one, because she's a woman. Two, because um, she is an African woman, right? Um, and three, because I think her position would give heed to the fact that no matter what, we're unstoppable and we are capable, and we're involved in all aspects of science. Dang, I wanted to find it. I guess the ancestors didn't want me to be petty. That sucks. But there was a part of the article that spoke on Pan African endeavors. Yeah, I'm gonna have to source that up now for real. And it was in the article in the Journal of Nature. So I think that was hot. But the other part of this, and before I get to her, is I'm going to show you this first and then we can go back. But this is part of her endeavor. Now, this is a South African radio astronomy observatory, and this is the SCA project. And this is something that's like current right now in astrophysics, the SCA project, which is an international effort to build the world's largest radio telescope with a square kilometer, 1 million square meters of collecting area. And so the SCA project is located in Africa and in Australia, and it will be an unprecedented scope and observation exceeding the image resolution quality of Hubble Space Telescope by that of 50 times. Yeah, I can't wait, right? While also having the ability to image huge areas of sky in parallel. Um, the South African Radio Astronomy Observatory is a national facility which is managed by the National Research Foundation and incorporates all national radio astronomy telescopes and programs. So, this telescope is located in the desert of South Africa, right? Um, and the sky part is practically groundbreaking. So I'll tell you what sky is. So the Mercat radio telescope, which Anthony, if he wants to jump in and tell you more, is one of their big telescopes that they've had for a while. This project is new. The Mercat was the predecessor to the project. So the Mercat is 90 kilometers outside the small northern Cape town of, what is that, Carnarvon. It's the precursor to what SCOT is, the Square Kilometer Array Telescope, which is integrated into mid-frequency component of SCA Phase 1. So this is something that's happening, that's going on right now. And guess who's leading the project? She's leading the project. This beautiful African woman right here. And this is Pont-Shu Maraping. It was hard for me to find like more on her than what they have, like basic bios, whether it was in the South African Observatory part. But I found this from MasterCard. And I'm gonna do a little bit more research, but I think this whole program is to highlight women in science. But this was a portion of some interesting facts about her. So she is considered like a self-described, let me do this differently. I'm sorry, I should have done that differently. I'll come back to it. Sorry, y'all. She's described a self-described career nomad. Puncha Marapang started her career in the late 1980s in the mining industry, working for De Beers. You already know that's them diamond people, and Anglo American. What? Let me not get triggered. Let me just finish it. What is that? Dang, I'm glad you got out, sis. She later joined the South African Department of Science and Technology, where she led various initiatives, including spearheading the establishment of South African National Space Agency, co-chairing the Science and Technology Committee of the Group on Earth Observations, chairing the Committee on Earth Observation Satellites, and serving as a South African Council for Space Affairs. Yeah, I left everything, but this is Pont-Shu Maraping, and I'm probably slaughtering her name, but for Women's History Month, we definitely want to pay tribute to these astounding women with their presence in science and actively engage and working now. And again, I think that's muy importante. So yeah, y'all go tell them that, Anthony and Juju told y'all, next time y'all hear anything about white men's science, tell them they gotta holler at our galaxy and beyond, because we pseudo killers and we killing it, right? That's pseudo. It's not true. It's a lie. It doesn't make any sense at all. And we have the evidence to support that over and over and over and over again. Doesn't matter if the entity is racist or there's racism, because you got to ask Percy Julian and some other people, Washington Carver, right? They still prevailed in spite of the racism, and their work speaks for itself. So I'm just, we're going to rewrite the narrative of how we speak on ourselves, right? And this is our way of doing it. Like Andy and Juju, this is how we gonna do it. We just gonna prove it to you. So this is Africa, and we showed you one in America. Both Black women, both belonging in science, which is far from a white man. Yeah. So I'll dock my yacht there, but yeah.
And but before you dock it, Miss Juju, don't forget about all the ones we did for Black History Month as well.
Of course.
You know what I'm saying? So this ain't just started this week for those the first time tuning in.
Right. Go ahead. Go ahead. Tell them about it.
You go back and look through February shows, and some of them shows we gave you even two.
Right.
You know what I'm
We
saying?
doubled up and still didn't get through all the people we want.
Hey, and we still got plenty more to go. You know,
Hakeem Olusei, you feel me? Soy Kiata. I really wanted to shout those people out, right? Sylvester James. Like, I could go on, but you know, I want.
And
go ahead.
I know on my end, I've been given all, you know, they've all had something to do with astronomy or astrophysics, but it goes beyond that.
Right.
You know what I'm saying? In all aspects of science, you can find people that look like us with major contributions to that field of science.
Right. So yeah, I mean, if you all don't have any further questions, I guess it did the key music, but you know, if there's anybody that still wanna, you know, hit the piano for about 10 more minutes, we might have time. If not, we good. You feel me?
Oh yeah, I'm good unless, like you said, if we got any questions, I'm game for answering questions.
Yeah, we'll give it a
as
few minutes.
far as the presentation,
Right.
You know,
But
it was short and sweet. You know.
Yeah, we gave you what we had, right? You know what I
Yeah.
mean? I mean, everything ain't got to be super difficult. And I think that's another misnomer. Oh, if it ain't difficult, it can't be. So that's not how things really work. Like simplicity.
Yeah. Nah, we gonna keep it simple over here.
Keep it simple.
As simple as possible.
Yeah. So I do want to say that I did leave a link to the South African Radio Astronomy Observatory, because that link, again, like the sky map and others, is very like quite interactive. They do have photos over there. Actually, it goes home about science students, outreach, resources, library, news, public open days, like and the for students part was pretty amazing, I will say. You know, that's my advocacy. There is a photo image library of some of the pictures that this telescope has taken, but there are different programs and outreach things. I don't know if they reach all the way to America, but it won't hurt to try if anybody is interested, you know. Or maybe you know someone who's in college who's looking to be an exchange student, and that definitely that's in that field. That definitely would be a good way to go through. Like, you know, they usually do like people also who are very engaged and know about it. It's like, you know, if you know, this has that, and you know, you have access to those programs and you know about them, then that's how you get in. So yeah, we just want y'all to know about them, whether in South Africa, whether in America, right? Because we're a global society. So, but that's a pretty awesome link. So check out those links in the description box for everything we've just discussed here. Everything we've shown you, I gave it to you. That's what we do. We're going to be transparent. Even about Jaga and Port Pod Show, you got that, so you can share it with your kids.
I got a question here, Miss Juju.
Go ahead. Where you at?
To Joe, yeah. It's growing every day, but at a rate that you wouldn't be able to measure. And that's simply because you have a lot of cosmic dust that falls to the earth. But as far as being able to get to a point to disrupt cause any kind of gravitational anomalies or anything, no, it won't happen. I mean, the earth is pretty much what it is right now. You know, that's about it. I mean, that's the simplest way to put it. No, it won't. The sun will be done destroyed us before the earth grows to any kind of level that it can cause any kind of disruption. What's happening? Kicked low,
right? Holla at the people.
Oh, he on mute. Oh, there you go.
We can't hear you.
No, like I said, it's not. It wouldn't grow as far as on a level that we could really see. There's material that comes out of volcanoes is just recycled material from the earth. You know,
Okay.
it's the earth's crust are materials that form the earth at a different temperature. They're molten. And, you know, you have these tectonic plates that are moving across the, uh, um, it's called the mantle, I
Yeah.
think, which is, you know, lava and all that stuff. And you have little weak points in the crust where that lava can push itself out. But it's molten rocks and land and all that kind of stuff. So it's not new material that's coming out of the volcanoes. It's actually recycled material. Now, redshift has to deal with light and the stretching of light. So when a light wave gets stretched to it as it stretches, it becomes, you know, red.
Mhm.
And as it compressed or more intense, it's blue. So they call redshift the fact that the light is, as it's coming towards us, it's being stretched by space and it
Mhm.
shifts in color. So that just lets us know that it's coming from a long way away. So that's basically what redshift would be. Where you at, Kick Dolo?
Yo, yeah,
Oh,
man, my
there.
bad. I had to damn sign on to the Wi-Fi out here. You already know, man. The connection out here is just difficult. Mondays and Thursdays is bad days for me, but I'm gonna try to kick it in. I'm gonna try to get in if I can, yo, just to build with the team. But nah, man, I appreciate what y'all doing. This is real good information. And like Anthony said, man, I do want to get in here with y'all some days, man, because it's one of my favorite subjects. So like, yeah,
Got
man,
it.
like keep it going, yo. Like I wish the show could go on for 3, 4 hours. Like that's what we need to be listening to.
Yeah.
Well, when you
If
come
it was
in,
up to
you can
me,
go
this
as
would
long as
be,
you want to.
man. Listen, if it was up to me, I mean, this is that real talk. This is talking about, what I mean, where we came from, like ultimately. You know what I'm saying?
Yeah.
Right.
Talking about the environment around us. Like you look up in the sky at night. I look up in the sky out here at the beach sometimes, and I'm like, yo, like we really floating in the middle of nowhere.
Yeah.
Yeah.
Right.
You know,
Yeah.
It's
I'm looking
perspective.
at stars and I'm right. I'm looking at stars and it's like, but I'm looking at millions of years in the past, so them stars ain't even like
Right.
the science of it all, yo, is just mind boggling, yo. So yeah, I
It
love it,
is.
Yeah.
yo.
It's absolutely fascinating. It's like the more I have to study for these shows, it's
Hmm.
like the better it gets every time. Like fascinating. You go from 5 billion years to 24 hours. You know the different ranges of how
Telling
star
you,
fuse, like stuff like that alone. You'd be like, wow. You know, it also humbles you.
yeah.
Yeah.
Absolutely love it.
It's just like
But yeah, so I
it's
know
just
we
like I was
changed.
saying on the brain show. Oh my bad. Go.
Well, I was just gonna say, I know we changed to Thursdays because I kind of want to fill it out how Thursdays would feel, being that we have Sunday shows. But I don't know. We may switch it back. But if you ever wanted to be on the show on Wednesdays is better, we could schedule it for Wednesdays. I feel like
No,
people
that's
can
no, that's
expect us.
whatever's good for y'all. No, that's whatever's
I
good
want
for
to be
y'all, man.
flexible. I just
Yeah.
say whenever we feel like we could be flexible. Wednesdays and Thursdays, expect us you know, I know Anthony's gonna be doing some more Space Age African Astronomy Club. Feel me? That would
Yeah.
pretty much be any day, but maybe we can reserve for Wednesdays. We could look for Wednesdays, then we could do other days, but we're working it out, seeing what's the best dynamic for everybody to get as much
Hmm.
participation and active engagement as possible. But what was you saying about the brain show?
Not well, it's like I was saying on the brain show. You know, as kids, man, we had these questions about how we originated, like where we come from, where we
Hmm.
at. Like you just all of a sudden you just look out and you're in space one day and you don't know what, like people tell you God created you, or you know what I mean, like
Right.
you just plopped here, right? And there's no real answers. But I feel like when you're talking about astronomy, you know what I mean,
Really?
and you mix it with the evolution, and then you're talking
Yeah.
Hmm.
about neurology, you're really starting to understand how you came to be. or at least
Fact.
the best or at least if it's not 100% of they know how we came to be, it's the best
Right.
explanation to how we came to be where we are now, right?
Right.
So man, I appreciate all those subjects, yo.
Well,
Absolutely.
it's like you say though, it's the study of the cosmos that really helps us understand. Okay, we understand how the chemically what makes us, we understand how that's formed. We found different types of amino acids and stuff that's in the body. They find them in asteroids and stuff like that. You know what
Yep.
I'm saying? So I mean, the science is the way to go, man.
Right. Look, the
I
study
mean,
of stars, like our sun, like it was like in school, then you find out like, yo, the sun is actually a star of trillions of
Right.
stars in the sky,
mm-hmm.
in the in the galaxy, right?
Yes,
And
one
then
of
you
Yep.
many.
figure out, right, and then you figure out it's like, yo, it's trillions of galaxies. This is like,
Right.
whoa, hold on.
Yep.
Right.
Man, it's mind-boggling, man. And then
Dude.
then you zoom down into the nebula hypothesis and how the solar system, and then you zoom into Earth and evolution, and then what I mean, you go through that whole process. Like, yo, like I love this group. I love the pseudo killers, man. I
Oh
love
yeah.
what we do, yo.
But you know
Right.
something, I totally understand why our, early ancestors believed the way they believed. I
Right.
understand why.
It's amazing,
But
bro.
what I don't understand is why people still want to believe that way. You know what I'm saying? I understand why
Yep.
they did it
We know
way back
better
then.
now. Right.
You know,
Yep.
I understand. But I don't understand why today
Well, it's
they still
scary,
want
yo.
you to believe like that.
You know what
You
it is?
know,
You know what it is, Anthony? It's scary so when you're giving a security blanket of there's
mm,
a agency out there that's looking over everything and just making sure that everything is safe, and then you somebody tells you like, oh nah, this like a meteorite or an asteroid can hit us today or tomorrow, we wiped out, like we don't, it's not promised for humans to be here.
Right.
You know what I'm saying? Like the asteroid, like how many extinction level events done happen?
it's what, about 6, I think, or maybe 8 that we
Right.
know of, something like that.
Right. So
It's been quite a few.
right. So when the more you listen to science, the more you understand like, yo, we still figuring things out. Like we don't
Hmm.
we don't know something, like everything ain't orchestrated and operating under some agency looking over us and making sure that we straight. So the
Right.
more you
Yeah.
veer away from that, away from that, the harder it is for your brain to predict safety,
Hmm.
right? Going back to the
Yeah.
brain shows, our brain's trying to predict, and so
Go
it's
ahead,
uncomfortable
connect
for
it.
those people.
Yeah.
It's uncomfortable for people, and it's a little unraveling, especially if you grew up in any religious setting and you just was told certain things. So it's, I can understand like people just, it's uncomfortable, and it's difficult to understand. You know what I mean? Because astronomy isn't like, I know we understand the little bit that we know because we love it. We intrigued by it.
Hmm.
But the people that ain't really got time to sit down and work out the whole chemistry of the stars and figure out evolution and figure out neurology and all of the other amazing subjects, like they man, to go to a belief system is easier, and it's just less, it takes less time to just say, yo, hey, God got us
Hmm.
and we good.
Yeah.
Yeah.
So I
Most
can
definitely.
understand the belief. I can understand why belief is easier to run to. You know what I mean? But
Yeah.
once you know
But
better, you
that's
do
why
better.
that's why I
Right.
stated a few minutes ago, Miss Juju, when I said reading, comprehending, and understanding is the superpower. Because ain't many people
Mm-hmm.
doing it. Most people just going
Nope.
on with their day, with their life, with their daily, you know what I'm saying, they routine every day. Get the kids up, get them ready for school, get them off to school, go to work, come home, cook dinner, boom. That's every day.
Whew,
You know what I'm
man,
saying?
it sounds like you just ran down my whole goddamn my
But
whole
it
schedule,
take a
bro.
little bit. It take a little bit of something extra in you to deviate from that to try to get an understanding of what's happening in a star. Most people are like, what the hell I need to know that for? You know what I'm saying? Well, one reason is getting an understanding for it, or your kids getting an understanding for it, can lead to a longevity in a career. Number
Yep.
one, they can make a living from this information. You know what I'm saying? And to me, that's the most important and exciting part about it, getting it to the young people, you know,
Right.
because this can take them somewhere, this information. I mean, look at all the people we've profiled on this show the last month and today.
Yep.
Those people started out, each one of them talk about how they were young and it was something that inspired them, whether it was Star Wars or Carl Sagan or whatever. You know what I'm saying? The cosmos is the place to be, man.
Yeah.
You know what I'm saying?
Fact.
Because it's a lot of unanswered questions out there. A lot
Yes,
of
sir.
them.
Yes, sir.
So yeah.
Like you said, man, it take, so like most of my learning, man, come while I'm driving. You know what I'm saying? Because I drive long distances. So while I'm driving, instead of I listen to my music, my hip hop, and all that sometimes. But a lot of time, man, I pop in the audio book or pop in a podcast talking about this very thing that we talking about, and best believe it's people that listen to y'all. It's people that go on their journeys or whatever, and they listen to what you breaking down and all that. So don't think that the information is going in vain, and it's very needed. Children are going to listen to this. This is going to be on YouTube forever. Until they shut down YouTube, which I don't see happening no time soon. So you know it takes, just like you say, it just takes people just setting aside even 20, 30 minutes, 45 minutes, what I mean, just to listen to some information that's going to help you learn more about your the reality, nature, and just learn something, man. You should learn something new every day, yo.
It don't cost you nothing to learn something every day, dog.
No sir.
You don't have to go out and buy a whole lot of books. And
Nope.
I mean, I'm like I say all the time, man. The reason why I understand and know the little bit that I know about the universe is because of something inside of me. Those were questions that I had. Whatever you want to call it, the mind, whatever it was. I could hear a little voice in my head telling me, man, you need to figure out what that is up there. You know what I'm saying?
Straight
And
up.
and and that's what pushed me,
Yep.
So that's
Curiosity,
why.
yo. Curiosity,
Um,
yo. The people. Go ahead, my bad, Drew.
I want you to finish your point, and then I found what I was looking for earlier. So, yeah, the petty gods are gonna let me win. So go ahead and finish your point, and then I'm gonna talk a little bit about some Pan Africanism.
Nah, man, do your thing. Man. I ain't mad. Hey, look. Hey, I think curiosity is the superpower, Anthony.
Oh
I'm
boy,
a
I'm so
curious. You know
funny.
me, man. I ask 1,000 questions. Y'all know me for that,
Yeah.
right?
And
And
you
I've been that,
and you should.
and I've been like that since a kid, right? And I
Me
know,
too.
people think, I do sometimes use it in my little battles or whatever, whatnot. But for the most part, I love asking questions because I just want to hear what the answers are. You know what I'm saying? And I try to compare the answers, this, that, and the third. But I think the curiosity among people is the
Hmm.
superpower that allows them to even reach the scientific literacy, reach the points that we've reached. I'm not saying we better than anybody or nothing like that, but in order to know things, you have to ask certain questions, right?
Right.
And
Yeah.
if you don't ask those questions, then you just ain't gonna know.
And the worst thing we can do, Kent, is turn a child off, a curious child.
Yep.
That
Oh
Right.
child,
man, what?
that
You
child is
will
asking
shut them
questions.
down.
You keep
Oh
telling them,
man.
stop asking all them questions.
Yeah, you don't want to shut a child down.
Don't do
Yep.
Don't
that.
do it.
No sir.
Don't do it. Well,
If
Don't
you
so,
do it.
so I'm gonna make
Mhm.
this point real quick, and we'll get back to the bill. But I was trying to find. I don't know why the petty gods wouldn't let me be great. But we were talking about female scientists in Africa, right? And how it's changing the face of the continent. Yeah, everybody go read this article, but there's one part and it starts with similarly. Yeah, here we go. This one's for you, Kent and Bobby Banger. It says similarly, the African Institute of Mathematics, Mathematical Science, that's the AIMS. You see how Africa has all these agencies for STEM, though? So I don't ever want to hear anybody talking any type of crap about Africa because it's going to be a problem. But the AIMS is a Pan African network of centers that has trained almost 2,500 students in intensive residential mathematics master's programs, with more than 800 going on to get their PhDs. So, right here in this article in the Journal of Nature, it talks about a Pan African network that's helping move along STEM on the continent of Africa amongst African women. But I'll finish reading. But how great is that, right? So, the African Institute for Mathematical Science is led by the educationalist Lydia Hakizimana, which I might feature her next because I'm really into this, African women in science thing right now, since science is only the white man stuff. Yeah, no, we're gonna it's not only white, but it's not just the man. You feel me? Because you have a African woman. We don't use racialized terms over here, so I wouldn't dare say black. They're African from different tribes, right? But coming
Okay, I hear you. Go ahead.
and its main goals include increasing the continent's number of math students and the representation of women in STEM fields. Yeah. And one third of its alumni are women. Yeah, that's a Pan African endeavor. Yeah, that's all I wanted to say. Thank you very much.
Hey, I have no zero problems with
I
that,
know, but
man.
but see, so what I think the problem is when it comes to that conversation again, and I'll keep saying it, I would challenge some sources, and I think it's very much mischaracterized, period. And the faces that we put on it are not the faces that need to be put on it. Like this lady's face actually needs to be on
Facts,
the Pan African milk carton. You feel
facts,
me? Because
facts.
she's a part of this endeavor. This is a Pan African. And so there is a video on the South African, what is it, radio astronomy observatory. Um, and though it does say that you can play the video, I don't want to take any chances. But it had a video of young African students, and it wasn't just indigenous Africans, okay? It could be some Afrikaners. They don't really call themselves because you have European descendant people that are in Zimbabwe and all the countries in Africa. Okay, that's been there for some recently, but some like over a century or two. You feel me? Like their great great grandfather came over there first, and they never left, right? So they would definitely be native, but they're not indigenous. But this video had everybody in that video, and they were young people talking about the impact of science on them or whatnot. So yeah, and I think that's important. So yeah, that is a Pan African endeavor, and it doesn't necessarily have to be look one particular way or be something that has to encompass race, right? But like I always said,
True
Ken, Pan
indeed.
Africanism has to do with the work. It's not about
True
people walking
indeed.
around talking about data Prince of Pan Africanism because where is that?
Hey,
Where
look,
is
we need y'all on the front lines on that on that
yeah,
on that point.
so so that's my piece. This is the face. Let this be the face of Pan Africanism, and Mugega Cooper and everybody else we talk about. So it's about rewriting the narrative and changing the perspective. And scene. I'll end there. Ah,
Hey, but before we get off of here,
yeah,
I
yeah.
wanna
Take your
this
time.
this what Ronald Perkins put on
Which
is
one?
spot on.
Oh,
You know what I'm saying?
I moved it. I'm sorry. I was trying to find it for you.
Which I was gonna go to that one next too.
I'll get
But
back. I'll get back. There you
I
go.
don't have a problem with nobody's God. Just don't try to bring him into the science. Then we won't, whatever motivates you, do it. If it's a head of lettuce, a can of Pringles, whatever it is, if it's gonna get you going, I rock with it. But this is what we're trying to change, Ronald. And you're absolutely on point with this statement. You know what I'm saying? So I feel like I said in the last show, a couple shows ago, it's our responsibility to uplift and show the examples that are out there that can change this narrative. You know what I'm saying? Yes, the back in the days, the ones, the more, or what you call the authoritative ones, yeah, they could control the information and how we got it. And not doing that now. This thing right here is more powerful than a lot of people's home computers. So it's a lot of information out there. Now, being able to sift through the information and to get to the root of it is a different thing. But you're absolutely right, man. It's on us to continue to push the scientific literacy and the STEM. We can't always think that somebody else is going to come give it to us. That's that savior complex. We got to get out of there. You know, waiting on that knight in shining armor riding on the white horse to come in here and save us.
Black
No.
Knight, yeah.
We got to put the work in ourselves. You know, that's why I stand on it. So
Roger
I
that.
agree with you 100% right there, Mr. Perkins.
Mm-hmm. Are there any other questions in the chat? Yeah, I'm getting older, y'all. I got to use them glasses.
Hey, well, you know they say wine get better with time.
That's
what I tell them.
Yeah, boy. Yeah, thank you. Shout out to Ronald Perkins and everybody else joining us tonight. Those were your final words, Anthony.
Yeah, that's it for me.
Kent, you got any final words?
Nah, man. I appreciate the people that's kicking it with us in the chat as always.
Absolutely.
Appreciate y'all, man. Always bringing that fire information, man. You know, that's, man. There's money came by. You know what I'm saying? That's value right there, man. So, you know, hey, peace to y'all, yo.
Yeah, you know I'll be trumping around with that little Pan-African article. I just want to let you know. But, you know, I gotta go to Discord and brag a little bit, like
Hey, look, but you know what I see? I wasn't gonna say this, right? But you know what I see?
What?
When I see like the lady y'all posted or whatever, or the Africans that you're talking about.
Here you go.
I see some humans. I see some humans that's dropping some dope information.
Perspective, of course.
As long as a human is dropping some accurate dope information, hey, look, that's all I see.
But that human is a Pan-African. I just wanna.
True indeed.
That's what's up.
Stop. I'm just kidding. Like this is some fun banter that we be doing in the Discord, y'all.
Man, it's all love. It's all love.
Most definitely.
But look, I'm sourcing up, Kent. You feel me? I'm sourcing up. I'm just saying.
Hey, that's a shot, and yeah, that's you got us with that one. But hey, and that's a good thing though. I'm glad that they producing that type of. See, I'd rather see that than
exactly. But that's what Pan-African does. Like even when we talk about the Great Green Wall in Africa, like it's weird because the so-called Pan-Africans ain't talking about none of that. And I'm just like, what are we doing?
They ain't talking about none of that. You're right.
None of it.
You're right.
What are we doing? Are you really a Pan-African? See, that's the thing. Now it's like, are you really a Pan-African? Like, what are you doing? You know what I'm saying? Pan-African is about the work, but that's our little additional added piece, though. And my final words would be like, this is my motto for 2024: is live life till the wheels fall off, and that's all I have to say. I hope you enjoyed this content. Anything that you may have missed or you need to find out, check out that description box. And thank you everyone for coming out. And with that,
make sure y'all like and share. Like and share.
Yeah. Like and share, And
always remember, when you're scientifically literate, they can't drag you down to their level and beat you up with experience.
All right, we out. I will let that be it. Bye.